Hi everyone, you all welcome to DevSecOps Nigeria. For those of us that are probably new to what the community is about, or we're new to the community rather, so DevSecOps Nigeria is a chapter under the global DevSecOps community. And what we do here is like DevSecOps global community is an inclusive community that educates and enables developers in application security. And DevSecOps is brought to you by Snake, and our aim is to create a vendor neutral space where we'll be able to share knowledge, best practices as well that are related to software security. So today we'll be joined by Steven talking about static analysis, testing and auditing for high-level programming languages like Java and other high-level programming languages. But before we dive into the discussion and the conversation today, I would quickly introduce myself. My name is Zainab, and I am the co-lead for DSC, which is DevSecOps Nigeria chapter. And our speaker for today, who is Steven, he is a highly skilled cybersecurity professional with over 6 years of experience in security engineering. He earned his Bachelor of Technology in Industrial and Applied Mathematics from the Federal University of Technology in Owerri. And he currently holds a master's degree in cybersecurity and networks from the University of New Haven. At the moment, he is currently a computer science student. He's doing his PhD at Howard University, and his research focus on advanced topics such as firmware update attacks, software security, and as well as machine learning in robotic system security. Stephen has extensive experience in cryptography, security research, as well as malware analysis. And his professional journey includes him working with leading companies like Aon, Apple, where he has contributed to enhancing cybersecurity framework and identifying vulnerabilities in critical infrastructures. So without further ado, I will hand over to Stephen, who will take us through the conversation today.
Um, Thank you for the warm introduction, and I'm happy to be here to discuss briefly about one of the very interesting novel techniques for doing security auditing for codebases, and I'm very happy to talk about this today. So first, I'm going to do like a brief introduction into um, what static analysis is and the sort of framework we'll be talking about, we're using today, and then what conversation we'll be having today. I'm just gonna quickly share. Just give me a sec. Oh, just give me a second. I'm trying to share.
Um, Apologies for the delay. We are trying to sort some technical issues from Steven end. Stay tuned. He is going to join us in a very short, in within the next few minutes. He is going to join back, and while we're waiting for him, just going to so
Yeah. Hello. Oh yeah. So we'll be talking about static analysis testing and auditing for high level programming languages. We talk about static analysis and how static analysis is a very great technique to find vulnerabilities And most importantly, we want to make sure that we catch vulnerabilities or loopholes earlier in the software development lifecycle, as it's very crucial. So I'm going to be talking about like some of the very cool techniques to find vulnerabilities in code, wherever in several types of languages. So first of all, I could sort of outline a short conversation would be talk about what static analysis and sort of introduction to the static analysis framework, um, like the demo case study and some sort of code snippet that I'm just going to demonstrate and just to talk about how the tool is very effective in identifying those vulnerabilities. What main takeaways are we from this demonstration and from this conversation, and then sort of conclusion. As well, know all security researchers and engineers, when static analysis is the process of analyzing code without requiring execution to find sort of bugs or vulnerabilities, and it's very useful for like 0 day discovery and those kind of threats and vulnerabilities that haven't been discovered yet or that hasn't made disclosed. It's very consistent, like results, and this is very proactive in nature, such that you don't. It's quite early in the software development life cycle, and you can actually integrate into your CI/CD pipelines, DevSecOps, as well as you can see consistent results, and you don't need to execute code in order to find like those patterns or bugs that you have under consideration. And the introduction will be CodeQL. So CodeQL is a was developed by GitHub in pretty about 2 years ago, 3 years ago, and pretty new to the field. And a lot of security researchers use that to find vulnerabilities during their development cycle. Um, it's basically it's for code analysis and allows researchers to scale the knowledge of a single vulnerability by developing scripts, and those scripts are called like the CodeQL queries. They're like queries that work in the form of like a sort of how you query a database. It has a database structure, sort of a relational database, and this is so cool in the sense that it makes your sort of procedure look like your code as a database, right? So you're gonna have a database based off the code base that you're analyzing. That database is gonna be used as uh, a sort of platform where you can query and get like results based off the patterns that you've defined in your script, your code QL script, and then it can go and query the database just like you're querying for information. You're trying to get important data, insight into database. So this is sort of like the flow. You have a query, you have a code, and then that transforms into database, and from database, you can actually get like insight into specific areas in your code where you have like those patterns that look like something you're looking for, or you're expecting some sort of like vulnerabilities or patterns that sort of malicious that can be exploited or taken advantage by an adversary. So I say source code is passed into a sort of relational database of facts and classes, variables, and you say like control flows and expressions that are of interest to you. And also introduces some kind of concept called the variant analysis, which you can use like a known vulnerability to use it as a baseline to find similar patterns or problems in the rest of the code base. So this is like the methodology, like sort of a workflow. So this works on multiple high-level languages. You can see Python works for Python, works for C++, Golang, JavaScript, and Swift. And just like I mentioned earlier, you just have like sort of extractor. So the extractor produces the CodeQL database. So you can have like a C++ file which you want to analyze for vulnerabilities, but extractor gets that into a CodeQL database. And that database is being queried. So you have like your CodeQL query at this point. So what it does is to um, is actually to query for those specific patterns and checks for users as sort of an untrusted input. You can have a function that receives an argument, the function argument, and maybe that receives a user defined, is user supplied, which of course could be like an attacker controlled variable. It also tracks like a sort of data flow path. So any specific variable that you're trying to obtain, track and see how, and that is being used throughout the code. So there's a kind of tracking mechanism that this framework provides to sort of get more visibility into how the data flow within maybe several functions, where several conditional branches, and and also the sync. It provides a sort of structure called the sync, where you can see like potential. You can use that to have insight into some sort of potential malicious functions, a dangerous function, and the end of the this process is that you have vulnerable patterns. You can see those vulnerable patterns like by just by the result of this query. So I'm just gonna do like a sort of demo to sort of illustrate how that works. So this is like a sort of code. Uh, Yeah, so to sort of demonstrate how to use this, so I've designed this piece of code, and this piece of code has a couple of mutually exclusive conditional branches, and part of my desire is to write a CodeQL script that is going to find some of those patterns in this code, and that essentially what this program is supposed to do. So I already developed the script, and how this works is that you can see you have like multiple mutually exclusive branches, and you can have command, you have trigger, and uh, as well as flags. So what this is going to do is to be able to detect um, these patterns, like very easily. So my script is actually going to find these patterns, and not necessarily um, I don't need to execute this code in order to find it. I don't need to run this code. But however, I just have my script, and what my script is going to do is to so I've actually developed a database. Like if you can go through like the documentation page, you can see how to generate a database um, based off from the code, and that works perfectly well. So you can generate a database and then import that database and choose what language you want to use. Pretty much a couple of languages. You have C++, C Sharp, Java, JavaScript. So as a case study, what I'm going to do is to run this. Is around this query. So I have a query that I've developed here. I'm going to run this against the database to see what results that I get. So I'm expecting to find some of those patterns, and then which are sort of mutually exclusive. And these are also techniques to find patterns um, that lead to sensitive information that could be transferred, or data that could be transferred between several branches in a program. So no matter how large a code base is, be it like 500,000 lines of code, you should be able to find all the specific things. It's pretty easy and very highly automated. So most of the work would be to write the script in such a way that it accurately finds this pattern. So there's a high level of accuracy, and in trying to find some of the vulnerabilities, this could actually be enable vulnerabilities. So whatever you want to find, whatever that you want to define, you can go through like the documentation page, you know how to write specific queries that could be tailored to your environment. So I'm just going to run this, and you can have like a view of how these are going to be detected. So I have a script which I already developed, and then I can run this, get a database, and database is based off this code that I've generated, and I can run that. And um, so it's like, oh, just give me a sec. Okay, so I'm gonna run this against the database, and here you go. So you see that I have a couple of them listed out, and so this I trade in and listen all those conditional branches that I've found, and then you can then go and do more proper analysis to find out what they mean. So this could actually tie into anything. It could be like buffer overflow, or you could find executor injection patterns, or any sort of vulnerability that you're looking out for. So part of um, the core responsibility would be to do some research to understand what patterns you're looking for and what sort of vulnerability that you're trying to find, and then look at the semantics, what is required, and then you can use that to find specific the specific patterns of vulnerabilities, and then which will aid to as you developing your products, you're developing your softwares and applications, you can at unit testing, you do this alongside your CI/CD pipeline. It helps to improve security, and also you can patch things up as you earlier in the development lifecycle, without waiting till at a later point to find out what has gone wrong or what vulnerabilities exist. That's saving more time. You're doing things like pre-runtime, like earlier, much more earlier in the process. So that's a very optimal solution, in my opinion, and that's and a great way for security researchers to um, kind of enhance finding more vulnerabilities in code bases and in application security in general. So I'm gonna bring back this. And yeah, so and sort of the main takeaways is that you have that this works in multiple languages, and just like I demonstrated, you can have like C, C++, Python, Java, Swift, and C Sharp, a couple of high level languages that they support. Um, so some of the work would be to try to find out how to interact with these languages, what sort of patterns and what sort of vulnerabilities are you trying to find, and then do more research into those, find the understand the intricacies of those languages, and then write your queries that's gonna be tailored to find those specific vulnerabilities. As a test and sort of kind of playing around with that, you can develop a piece of code and then find specific patterns that will be I'll develop in that piece of code, develop specific patterns that you're looking for, and then write a script based off that, and then use that script to target. So develop the produce the database based off the code, and then you should be able to find the patterns you're looking for. So that makes it very effective, and um, most detection vulnerabilities. Most detection techniques for vulnerabilities like this will probably use like in runtime execution, but this is pretty much early, so you catch some of those bugs earlier in the application lifecycle, as opposed to waiting till a later time to do that. Um, Secondly, it also gives like details and definite conditional branch statements, like from the experiments that I gave, and I also analyzes code as data and not a runtime behavior. So I literally just had to run a script and then find the vulnerabilities. In those patterns, I can go and then do further analysis and know what does this part of the code mean, and how can we really enhance this so it doesn't have this pattern. So is there some sort of patching that we need to do? um, and then find and actually get more security posture within that product application that the organization is trying to ship out. Um, so, very interesting thing about it is also that it just helps you to develop this sort of relational database, which has a sort of kind of relationship, which is kind of interesting and fancy. You can then use that query that table like you're querying a database, right? So that's pretty much like how this works. So you just query the database and then get all those information right after those patterns, and you have that visibility into um, those patterns or those vulnerabilities you're looking out for. And a situation where you run that and that doesn't bring any sort of concern, or there's no results, okay, my code is pretty secure at this point. It gives you a high level of confidence that um, we don't have any sort of vulnerabilities. Like I said, it's very useful for 0 days. So some sort of you can have a clear sort of vulnerability that's existed some way, or you feel strongly about a certain type of dynamics of maybe propagation or the syntax specifics within the code that you could think about, like maybe like an adversary you can simulate, and then code that idea or the simulation into your automation, into your script, and then target that code base, maybe from the database, and then get feedback based off of those. So it's very interesting, and like analyzes code as data, and it's pretty fast. Like it saves much more time, like more runtime, runtime sort of vulnerability detection or checks. So this is pretty interesting, and I'm very glad that um, I got to talk about this today, and also like introduce to the community, and security researchers all over the world can start playing around with interesting stuff like this, and it gives a lot of leverage, very flexible and scalable as well. As a scalable, that's the very interesting part, because no matter how big your code base is, you can also use this to find a lot of like very interesting things and vulnerabilities within your code, and just as you're developing, you're testing, and that helps to improve security. And I hope like people would, and professionals throughout the world would leverage this opportunity to get into more security research, and do more great things in making sure that what is a very secure place. Um, thank you so much.
Yeah. If we have a question for Steven, we can drop it in the comment section. He's happy to take questions. So before we go towards rounding up the session, I believe we've learned one or two from the demo and from the conversation. So if we have any question for him, let's drop them in the comment section so we can use the next few minutes to answer that before wrapping up the session. On a lighter note, and in the absence of no questions, I would like to say a huge thank you to our presenter, Stephen, for the informative session. And we hope to see you on again sometimes in the future. And to our viewers or joiners, people in the community, apologies, and we're really, really sorry for any. We're really sorry for issues because we had some technical issues along the line. So we're really sorry for that. And sorry for starting late because we're a few minutes behind when we started. So we're really sorry about that. So while we're waiting for questions, and it seems there are no questions for Steven, so I would like to say thank you all for joining us, and I hope you've enjoyed the session. If you joined late, don't panic. there will be a recorded version of this session. Immediately the session ends, the recorded version will be out, so you can listen to that later. And while after watching it or while watching it, if you realized you have any question for Steven, please feel free to join our Discord channel. We're all encouraged to join the Discord community because that is where the conversation happens. And the link to join the Discord is on DevSecon Global main page, so you can join the Discord community there, and we're happy to answer any question you might have. It might even not be related to this particular session. And as well, the link to this recording will be shared as well on the Discord channel, so we can always rewatch it when we want. And if we want to share with friends who we feel might benefit from the discussion, we're happy for you to do that. And I would say thank you for joining us today, as that will be all. And so thanks everyone for joining us. I know it's Friday evening, you probably had other plans, but thank you all for joining in. And I hope you enjoy your weekend. So, Stephen, thank you for joining us. We really appreciate the time.
Oh, sure.
And I would say enjoy the evening, everyone, and have a great weekend. So, bye. See you next time.
Bye.